cyclohexanol here. And then what I'm going to do is it's going to react with, this is sodium dichromate, so Na2 Cr2O7 with acetone as its solvent, and then I'm going to I have H2SO4 as its sulfuric acid for acid workup, right? So I have a cyclohexanol. What it's going to do, again, for this reaction, it's going to oxidize it, right? Draw the correct organic product for the following oxidation. So if it oxidizes this reaction, it's just going to simply create a ketone, right? So simply here, it creates a ketone here. So this solution is, again, correct, right? It just creates a ketone. So this here is a correct solution. Again, I have a hexagon, and then I simply have a ketone here. It converts because I have here a secondary alcohol. This here is a secondary alcohol. It's bonded to two other things, right? We know that it's a secondary alcohol. I can't actually oxidize it even further to become a carboxylic acid. Like I wouldn't get something like this. I wouldn't get something like this. A double bond here and bond OH, like that doesn't make sense here. Like this would not make sense because if you count the carbons here, I have five bonds, right? 1, 2, 3, 4, and 5. Let me draw that out. Of 1, 2, 3, 4, and 5, carbon with 5 bonds is no good. This does not produce it. It just cannot oxidize it further into a carboxylic acid. It only stops at a ketone here. So this here is a secondary, again, secondary ketone, and we are good to go. So this here is an oxidation reaction of a this is again cyclohexanol becoming cyclohexanone. So this here is a correct answer. This here is it oxidizes, converts secondary alcohol to ketone. So this solution here is correct. Great solution and answer. And again, we can't oxidize it even further because this is a secondary and not a primary alcohol. Again, secondary and tertiary alcohols don't stop, they stop oxidation at the ketone or the aldehyde level, and they don't go towards carboxylic acids. Only primary does. So it's a great solution and analysis, I'm going to say. Analysis. Solution is correct.